What's good, guys? In this video we're going to start talking about classes and how they are one of the most powerful tools at your disposal in the C++ language. But before we start talking about classes, let's sort of give a context of the creation of classes and why they came about. So in the C language, if you learned about C, and maybe if you learned some C++ beforehand, you may have learned about the keyword struct. And what struct lets you do is that it allows you to create something that I like to call an abstract structure that contains data. And that is a user-defined type. So with this user-defined type, the use of struct would let you create your own data types essentially. And they would act as containers of, it could be one data type or multiple data types inside of it. But there are two problems with structures. The first is that when you initialize them, the internal data that's inside of the structure is just declared. The memory is reserved, it's uninitialized. So by initializing a structure, you're not automatically guaranteed that the contents inside of it will have a value that's 0 if you're lucky. And there's the possibility that it could just have junk, and that can mess with your program in many ways. The other thing is that while structures are nice because they have members and variables that are binded to it, you can't bind functions, and sometimes it feels that there should be a way for you to bind functions to structures. Well, there should be an easy way to bind functions to structures. You can, but it gets a little bit complicated. So to kind of highlight that, let's take a look at this program that I wrote. So here I have a structure. I call it point3d. It has three members that are associated with it. X, Y, and Z. They're all doubles. And then here, because I don't want to be typing point3d all the time, I use a type def. I'm going to redefine struct point3d with underscores to point3d this way. So that way it looks nice. But then, like I said before, on line 12, I just create point3d. And my immediate question is, what is stored inside of X, Y, and Z? Well, if I'm lucky, there will be zeros. If I'm unlucky, there could be random weird junk that's been left over from some other program. And when I think of a 3D point, there are a few things that I'd like to do with it. Maybe I'd like to set the values of X, Y, and Z, or maybe get them. Maybe it'd be nice if there was a print function that was binded to the structure so that way I can print it without having to look for or even create a function to print the members inside of point3d. However, right now at my disposal I can only create functions that can do this for me, and they look like this. Here I have a function called Setpoint, which takes a struct 3D pointer and three doubles. What this does is that it takes this pointer and we look at every single members associated with it and we set it equal to the values of our inputs. So if I have my point P and I have the X, Y, and Z coordinates that I'd like to set that point to, Setpoint will do that for me. Additionally, I have a function called printPoint, which takes a pointer to a point3d and we print the contents of the structure. So why don't we test these two functions out? Here's how I'd go about calling them. Because each one of these takes a pointer to point3d, I need to provide the address of my variable p. And then here I'm looking for three doubles. However, I just put some integers right here just to keep it simple. So why don't we run this code and see the output now? I forgot that after the type def I can't do something like that. It needs to be point3d, and the same has to be done here. So now that this is done, we can run it correctly. And so far this implementation is pretty simple. I'm able to call my function. My setPoint works because it was able to set my 3D point to these three values, and printPoint works as well because it printed it just as exactly as I wanted it formatted. But Wouldn't it be nice if these functions were bounded to P? If I could do P dot set point and something like that? Well, through something a little bit esoteric called a function pointer, I can kind of emulate this behavior. Why don't we take a look at that? Here we are, and things have just gotten a little bit complicated. So don't pay too much attention to this, but here I have a pointer to a function that can point to set point, and here I have a pointer to a function that can point to print point. So what I do here is that I create my point 3D called P, and I say that, okay, this function init, I'm going to set it equal to set point, and this function print, I'm going to set it equal to print point. So here I call it kind of like how I'd like to use it. I say p.init, and then, oh man, I have to give the same variable that's calling this function, I have to pass it as an argument, as well as the normal values itself. And here with pprint, I have to pass itself as an argument again. So this is a step in the right direction that I'd like to do, but my first problem is that I'm still using the variable that's calling this function as an argument itself. And the other thing is that for every P that I create, I'm going to have to do something like this. And this can get kind of annoying. But anyways, let's look at the results of this program. And the result is the same. So this is pretty cool because I kind of have added some upgrades to my struct that wouldn't be traditionally there, but this is still not enough. I mean, you know, I've added some neat things like I kind of have this thing where I can have functions that are pointing to the structure, but every time that I create one of these structures, I need to set them equal to these functions, and they're right here too. So this is like it's kind of, there is a capability of having functions that are binded to the structure, but it's not really there. This is a complicated workaround, and this can get really troublesome because if I have to do these 3 lines for every time that I declare a point 3D, well, I mean, that can get annoying really quick. However, the fact that I have something like this, that a function's binded to the structure, that's pretty useful. That's really useful. And it would be awesome if I could do something like this instead of what I have here. Right, so instead of having these 2 lines, and oops, I made a mistake here. I need to swap this here, swap that there. So instead of having these 2 like I do right now, I can do something like this. This feels a little bit more intuitive. This feels like, you know, there's a function that's properly binded to the structure. Now, C doesn't provide that for us, and actually all this code, even though I've written it with a C++ syntax, this stuff right here, you can do this with C. However, this paves the way in introducing one of the best tools that you have available to you, and that's the class. So we'll see how the class solves all these problems and can do so much more. I'll see you in the next video.